Alright, so let's go and take a look at the world's hardest derivative you will ever take. Number 4 down here. Now, one thing we noticed, first, we don't like this cube root, so we're always going to rewrite that. We don't like cube root. So I'm going to write this as x squared plus 2 to the 1/3. And hopefully you kind of realize that we do have a chain rule here because we have this x squared plus 2 inside this 1/3. But we also have this gigantic quotient rule right here. So again, we're going to go back to that big picture thing. And in the big picture, even though we have this quotient rule, we have this chain rule down here. This quotient rule takes a bigger part of the problem. So when we take the derivative, we're going to do the quotient rule. Be slow with this. Now I promise you, eventually you can get really good at this. You can do this in 2 steps. Okay? The first thing we do is take the bottom, which is this x squared plus 2 to the 1/3. Multiply that by the derivative of the top, minus the top function times the derivative of the bottom. Now the bottom, that's our chain rule. The outside is this 1/3 power, so I'm going to go 1/3 x squared plus 2 to the negative 2/3. That takes care of the outside, but don't forget you got this inside part too. 2x. Take the derivative of that inside. Divide that by the bottom function squared. And that just becomes 2/3. Okay, this is super ugly, but look, that's my derivative right there. That's all the calculus there is. Now, the one thing people tend to forget is this. Don't forget about that 2x, okay? Now, we have 2 things we don't like. 1, we have this negative exponent, and 2, we have a complex fraction. So when we take the derivative now, when we simplify this, the bottom is always going to be this x squared plus 2 to the 2/3. On top, I'm going to put that 5 out to the front here, x squared plus 2 to the 1/3 minus, but this long term right here is a fraction. So I think what goes on top, what goes on bottom? The 3 goes on bottom, and so does this x squared plus 2 to the 2/3. That's what that negative exponent means for us. The top and everything else goes on top. That's the 5 and the 2 and the x's. So the top just becomes 10x squared. Simplified. All right, now eventually you're going to go from here to here. That's where we want you to get to. Now we're going to multiply by the LCD, top and bottom. The common denominator is going to be this 3x plus 2 to the 2/3. Top and bottom. If you just slow this one down, please do so. And this will give you your final answer. F prime of x will equal, on the top, if I distribute here, I'm going to take this 3 times the 5, and that becomes 15. Now be careful. If I take this x plus 2 to the 2/3 times this x plus 2 to the 1/3, we're going to get x squared plus 2 to the 1st. Minus, and this whole thing cancels out when I distribute. So we're minus 10x squared. On the bottom, we're going to get 3, and we get x squared plus 2 to the 4/3. And there's your answer. Leave it alone. We did a lot of work. Like I said, you can get these done in 2 to 3 steps. Of course, if you did write, on your test and quiz, we're going to say write this as a single fraction. Now, on your test or quiz, especially multiple choice, it might have the answer as 5x squared plus 30 over 3 times x squared plus 2 to the 4/3. But you don't have to do that unless it's multiple choice, like on a quiz or test or something like that. Okay? All right. That's a tough one. If you need to slow it down and watch it again, please do so. You will like it. And now it is time to get triggy with it. So let's take a look at some trigs with the derivative. Oh no, before we do that, I forgot something. How do we use this for a tangent line? Again, you can see tangent lines all over the place. So we might recall we're writing the equation for a tangent line of this function at 0, 4. You might recall the first thing we need is a point, 0, 4, and then we have to get the slope. Now notice how I write it. I start from the left and go to the right. Taking the derivative, we're going to use our chain rule again, right? My outside function, my inside function. So my derivative, f prime of x, will be 2 times 4x cubed plus 3x minus 2 to the first times the derivative of the inside, which is 12x squared plus 3. Don't forget your parentheses here. And then we're going to plug in our slope at 0, f prime of 0. So we know x here is 0. I can just plug it in. 2, 0 plus 0 minus 2 times 0 plus 3. And if we simplify all of that, what do we get? Negative 12. So to write our tangent line now, we would get y minus 4 equals negative 12, x minus 0. And I leave it alone. Even though I don't have to put the 0 there, I just leave it alone. I just get an answer. I train myself, I'm just going to get an answer. All right, now let's get Triggylicious with it. Question number 6, trig function. These are really easy to see. The outside function is obviously our cosine, and our inside function is at x cubed. So when we take the derivative, we take the derivative cosine, which is negative sine. But remember, we're leaving that x cubed as is. And then we're going to multiply that by the derivative of the inside, which is 3x squared. Remember, d out, d in. Leave it alone. You can clean it up if you like to. We're not interested in that. Just leave it alone. So number 7. Oh no, look. We do have a chain rule right here. This is a chain, and this is a chain. Oh look, we have 2 chains. I wonder if that's how that rapper got his name. But the big picture here is product rule. So even though we have 2 chains, literally the big picture is the product rule. That's the biggest part of the graph, of the equation here. So this is a product rule question. That is our big picture. So when we are just taking a product here. So when we do the derivative, remember our product rule, it's the first cosine of 2x times the derivative of sine of 5x squared, but that's our chain. That's going to become cosine of 5x squared times the derivative of my inside here, 10x. Plus, now the second, which is sine of 5x squared times the derivative of the first, which is negative sine 2x. Don't forget, take the derivative of the inside times 2. I ran out of room there. Kind of squeeze it all in. Remember, don't forget the inside derivative. Don't forget the inside derivative right there. That's our chain rule, and there's our answer. Don't clean it up, just leave it alone. So let's see if we can try number 8. Now this one people always mess up. Recall that the derivative of cosecant of x is negative cosecant of x cotangent of x. So I'm taking my derivative. There's my outside function, and there's my inside function. There we go. So when we take the derivative, it's cosecant, so we get negative cosecant, but not x. X is replaced with 7x to the 5th. So I'm going to write that as 7x to the 5th times cotangent 7x to the 5th times the derivative of the inside. Don't forget the derivative of the inside, right? That's our chain rule part. 35x to the 4th. And there is our derivative. Okay, a secret way to do chain rule is this. Okay? It's f of, if y equals f of u. Okay, I know what that says. Okay, if we take the derivative, we can write this as f prime of u times du dx. I don't really necessarily like this notation when you're first learning calculus, because u is basically a function of x. I don't really like that much, but sometimes it helps for a problem like this, where if we let, for example, here, and I'm going to do this on another sheet of paper here. Give me a second. If we let u equal 7x to the 5th, I can then write f of x as cosecant of u. So therefore the derivative would be negative cosecant u times cotangent u du dx. So du dx, okay, we'll talk about that in a second. So my derivative, now I just replace cosecant, u was 7x to the 5th, cotangent, which is again 7x to the 5th, times the derivative of u with respect to x, 35x to the 4th. We get the same thing, but I really don't like that notation. Just know the rules is much quicker for us. All right, number 9, again, this is kind of a challenging one for some students. Okay, so if we take a look here, notice we have this 4th power. This is hard, so we don't like it. We're going to rewrite this as cosine of 5x to the 4th. Always rewrite this. People who do this never miss it. People who try to do it this way, most of the time they get it wrong. But everybody who does it this way gets it right. So my derivative, we have an outside function, and that's going to become 4 times the cosine of 5x cubed times, let's look at the inside, it's my cosine negative sine of 5x, but there is a problem. There is another inside function. It's another inside. And the derivative of 5x is 5. So you always are going to rewrite these. Makes it easier for us. And there's my answer. Of course, if you clean it up, you would get negative 20 cosine cubed of 5x times the sine of 5x. And you can use your identities and clean it up a little bit more. All right, if you go to part 3, we'll take a look at the last few examples here real quickly, okay? So go to part 3, we'll take a look at those.